Okay. Hold on a second while I get the link for this. I apologize, I'm a little bit late today. I have had a very interesting afternoon. It's been a very busy day. Get the share link. Check to make sure that this is actually working. So there's no guarantees. Anything's okay, it's showing up. I just get so excited when things work, right? All right. Posting the link to today's lecture. Okay. Paste. It's fun watching your professor deal with technology, isn't it? This is what all of you signed up for. You thought it was to learn. No, it was to watch people. That's really all that this is. It's just watching. Okay, the link is now live on Blackboard. Late, but it is there. My stream is live. It's been a day. Okay. So what we're going to do today is what we've done over the past few days is we have been working to design a well, I've been helping show you my process on designing a Pancake printer. I've come up with a very, very simplistic model of a Pancake printer. I've showed you how I did it. You have every ability to make it much more complex, more complicated than I have. If you just want to recreate what I did, it's not going to hurt me any. I think at this point in everybody's lives, we need a little bit of simplicity. So if that's what it takes to get out of this class, then so be it. What we're going to talk about today is once we have our model for the professional display and the professional looking very nice design, how do we take that and create an actual display of it so that we can professionally show people what it is that we made so that they themselves can make decisions on whether or not to go with it, how to build it, how to build on it, that kind of a thing. Okay, so gonna go ahead and switch views real quick. Hopefully my desktop camera doesn't go out again. I'm gonna leave this screen kind of up. I'm gonna go ahead and pop open the Pancake printer assembly that we've been working on in SolidWorks. Again, remember, if we were to copy, if you wanted to just send me this assembly file, you would have to send me every single part file in the assembly. That's what you kind of have to do. And every single assembly file that's also in that assembly. And this is why you need to organize your files. I have this saved nicely into one single folder. And the reason for that is because if I need to make any edits or if I need to make a version 2.0, I can go back in, I can edit these files, but I can keep them all together. No, wait, I want to take a survey. But I can make those decisions later in the future. And having them all together in one folder means I have all the parts, all the assemblies. I don't lose anything, I don't have to rebuild anything, everything is already there. Even if you're going to delete out parts, it's a good idea to copy everything into a brand new folder and then edit the assembly. Okay, so now it's updating my assembly. It's Updating the graphics. And there we go. Now I still have temporary axes and planes visible on this drawing. So pop up the chat so that I can see if somebody has a comment. Where's my mouse? Go ahead. Free up some space for my mouse. So here is my Pancake printer. Okay, if I just simply throw this drawing at somebody, it probably would not be good enough. The unfortunate nature of professionalism is that we can't just hand somebody a 3D file and expect them to understand it. As an engineer, I can sit down and I can pick apart this 3D file, I can pick apart this SolidWorks file any day. That's easy for me. If you were to put this into a 3D printer program, or you were to put it into some kind of a manufacturing program such as the CNC lathe or the CNC mill, it could actually cut this material out and it would want the 3D part files. So for somebody who has experience with this, yes, they like the 3D part files. For machines that require the 3D part files, it's great to have. But for most other people, and this includes even some modelers, some engineers, it is best to be able to give a concise, nice, neat drawing file. Because believe it or not, this drawing does not say everything that we need it to say. Okay? So how do you do that? Well, we're going to go up to File, New. So far in this class, we've covered parts and we've covered assemblies. And yes, there's a big difference between a part and an assembly. Yes. Now we're going to get into drawings. What is the difference between a drawing, a part, and an assembly? Well, a drawing is like an assembly, but a drawing in that assemblies don't save actual geometry of parts. It only saves relationships between parts. That's all it does. That's all an assembly is relationships between parts. Drawings take those pieces and it allows you to display them, put dimensions on them, and turns it into a 2D format. Okay, it's a lot like the AutoCAD layout tabs. So I'm going to go ahead and click on drawing and hit OK. Takes a little bit for SolidWorks to go. And then it automatically pops up and says, alright, what sheet format do you want to use for your drawing? I have developed a custom sheet. I don't want to use it for this class. I feel like it would just be best to use the existing one. An ANSI landscape sheet, what this is it's got the height in millimeters. This is 10.5 by 8.5 by 11 sheet of paper. Okay, it's pretty standard. If I go ahead and hit OK with ANSI landscape, most of the drawings are done in landscape. You can do them in portrait if you really need to. This is what the format looks like. It comes in, it has these two sections on the side here, it shows A and B. It's kind of like a map. If you wanted to locate, and say you've got a really complex part here, you can say, well, look for that part in section B1. It'll be in this quadrant here. Or maybe this drawing will be divided up into 4 spots on top or 4 spots on bottom. You'll be able to pick it apart and map. That's another nice feature that just distinguishes where you can find parts on this sheet. If I zoom in real quick, this is the title block that comes in standard. Has a spot for you to determine how much tolerances, what the fractional tolerances are, what our machine and bend tolerances are, what 2 decimal place tolerances, 3 decimal place tolerances. So if a number shows up as having 3 decimals, what's the tolerance on that number? This has who is the engineer who approved this, who's the manufacturer who approved this, who reviewed these drawings, who drew these drawings, who commented, any comments that you have on the state of the drawings, title of the drawing, drawing number, the sheet size, the scale of the sheet, the weight of the paper. I mean there's a ton of information here that is included in a standard title block in SolidWorks. Over here you've got what revision number it is. This is if you're drawing something like a Pancake printer and you submit it to somebody, you come back and you have to copy your folder of files, a brand new folder. You call it, this is now Assembly 2, and you would document what day it is. What this title block is it's the ability to really finely document every aspect of your design. I've said earlier this semester, you cannot assume that people just understand your brain. You have to be explicit in everything you tell people. Okay? You say, hey, go build a staircase. You as the engineer say that. What somebody else may hear is, hey, go make a sand ramp. Now that's not what you wanted, but you weren't very specific in how you said it. You said build a staircase. Well, what material do you use? How much of that material do you use? What kind of connections are going to be needed for that? Where are they going to get these materials from? What are their part numbers associated with that? Is this a design that you have already, as a company, already used before? All of that information is necessary, and if you don't include it, you can't assume that somebody's just going to know that. Basically, you have to draw things such that somebody who has no idea anything about what the company does, all they know how to do is read technical drawings. They can come in and exactly reproduce everything in your drawing without having to ask you any questions. Okay, any of those questions that they would ask you need to be answered in either notes or special call-outs in the drawing. Okay, so when I open up this sheet, the first thing that it tries to do, SolidWorks wants me to add a part or an assembly into this design. Now I've already got the assembly open, so I'm going to go ahead and do that. Usually the way that assembly files are set up, or drawing files are set up, are that the first page is an assembly, second page is either a sub-assembly or a bill of materials, third page would then be the sub-assembly, and then fourth page would be parts in that sub-assembly, etc., 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 then another sub-assembly, then the parts in that sub-assembly. And so it's organized from top down. You start with the big picture, and then you build out the little picture as you go farther down the document. Okay, so I clicked on assembly. My mouse cursor, as it moves around, wants to put down something. What is it putting down? Well, it's putting down a front view of that design. So if I just click, that is the front view of my Pancake printer. Okay, what is the front view? Well, it's looking perpendicular to the front plane of that Pancake printer. Okay, dang, I already don't like what I did. Let me go ahead and delete this. Yes, delete it. Go into view layout. I'm going to go ahead and you can do a standard 3 view. Pick assembly. And then it'll automatically generate a standard 3 view, front, side, top. Done. Very easy to do. Okay. Now let's say we want something a little bit more specific. If I click on this and I hit delete, I want to delete this. I want to delete this. I want to delete this. You can put in views individually by saying, I want a model view instead of a standard 3 view. Standard 3 view will do 3 views automatically. You can reorganize them on the sheet. The nice thing about SolidWorks is it likes to organize them so that they're on top of each other. It automatically does that. A professional design of a part or an assembly features a front view, a side view that is aligned with it, and a top view that is aligned with it. You can see this arrow, well, this line that's showing up right here, that is the alignment. You'll notice all my lines line up. Here, if I were to trace a line that goes from here to show where the bowl is, it would connect with the edge of the bowl there. Okay, the edge, the outside of the device here aligns with the outside of the device here. Okay, all of my lines align. Now while I'm doing a model view, this is now, I'll hit escape. Say I got my standard 3 view in place. I can grab this, I can drag it around. It looks pretty awesome. What I'm going to do here, I'm going to click on this and I'm going to click Projected View. Okay. Now, Projected View is when you have a model view and you want to show a different angle of it. Okay, so these views, this view here and this view here, those are projected views already. But the view that I really want to create is this isometric view right here. An isometric view, it's at a looking down, not directly along any of the axes. I'll go ahead and hit OK and drag this over. And this is my Pancake printer. Okay, I've done none of the work in filling out these sheets. Awesome. I can always double click in this. Oh, you go to edit sheet format, you right click, edit sheet format, and then you can change the names of things. Like for example, I don't want this to say assembly. I want this to say, oh, you know what, I'm going to make it say assembly. Whatever. You'll notice that SolidWorks already updated the scale. It no longer says 1 to 1 anymore, it now says 1 to 8. So if I hit right click and I go to edit sheet, and I go back and click on my model, what happens is SolidWorks tried to make this so that it fit in my drawing. It picks a size that's about right, and it automatically used the sheet scale of 1 to 8. It actually set the sheet scale at 1 to 8 just to fit this drawing in. So SolidWorks does a little bit of work behind the scenes. If I don't like that, so I've got this model view selected, I can go back and click a custom scale and I can say, I don't like this. I want a 1 to 12. Okay, and then everything gets smaller. You can change it so that this model view is 1 to 12 and this projected view is 1 to 8 or 1 to 4. Some things I will sometimes do is if I want to have it be where the model views themselves are small but then the isometric view is fairly large, you can do that. I can go in with all of these being a scale of 1 to 12. I can then click this and go down and change this as using the parent scale, not the sheet scale, the parent scale. 1 to 12. I can use a custom scale 1 to 8. Okay, or I can click on use a sheet scale, and which is already at 1 to 8. Generally, unless it is absolutely impossible to do, you want to keep everything on the sheet scale because it already shows up. What that means is somebody could take a ruler if you didn't dimension something well, or if they have a question about the distance between this piece and this piece. In theory, they could still go back in, measure it with a ruler on a printed sheet of paper just like they did 20, 40, 50, 100 years ago. Okay? Measuring things by a ruler was the best way of being able to transfer that knowledge without actually having explicit dimensions. Now that's not common, and if you do a good job of dimensioning, nobody ever needs to do that. But that is how you would adjust the scales. Scales are important on all of these professional sheets. Okay, I'm not going to get too big into how to modify the sheet format down here. I'll cover that a little bit more in the next drawing, and I'll show you kind of the final design of how I want this to look. What I want to do for today's lecture is I really want to focus on how do you get the layout to look nice. So here I've got this sheet layout. What I may do is I may put a note in here that says, this is a Pancake printer, it says electrical wiring hookups, that kind of a thing. What I am going to do right now at the very start is I'm going to go into my annotation, and I'm going to go into my balloon, click on balloon, and I'm just going to float around here. Now what is a balloon? Well, I'm going to show you. First thing I'm going to do is I'm going to click on this housing right here. Okay? When I click on this housing, it shows up as the number 1. Okay, what does that mean? Okay, I'm gonna go in and here, this part here is my heated plate. Click on it, shows up as a number 2. Okay, I'm gonna go in here and I'm gonna click on this bowl. That shows up as a number 5. I got this bar, that's a separate piece. There's number 3. I got these little longitudinal bars here. I click on those, that's part 4. Click on the other bar. Should also be part 4. Okay. What does this do? Well, this drawing here is not, I mean, it's a fairly complex drawing, and it's kind of hard to figure out what parts are what. In this view right now, if I click on the isometric view, right now it's a hidden lines removed solid. I can change this to be shaded with edges, which will bring in the colorations that I had set in the assembly, which is what I want. And with this view, it's a lot easier now to tell, oh, that's something different. If I were to go back here, this is a little harder to see. Some people may like it with the hidden lines, but with this isometric view, I want this to be here. What this does is this allows us to say what parts comprise this assembly, where are they located. Okay, a lot of what the sheet shows is what is this supposed to look like, where are all those parts supposed to be. There's no real good way of showing how things are connected unless you want to do an exploded view, which I can show you how to do that too. There's not a really good way of showing how the parts fit together in 2 dimensions for a 3-dimensional object. So we have to do what we can. Showing the part numbers is needed. On all good drawings, they will always show the part numbers. These part numbers, you'll notice I didn't have to specify what was 1, 2, 5, 3, or 4. I didn't have to specify that. Why? Because those part numbers are automatically generated by the assembly in the assembly document to state this assembly 1 consists of parts 1, 2, 3. Assembly 2, which is a sub-assembly to that assembly, is 4, 5. That kind of thing. So all the part numbers have already been specified. All this drawing is taking is that information, all the relations, all the information that was imported from that assembly, imported from the parts, which is way, way more than just the 3-dimensional pieces. It includes information on materials, it can include information on properties, all of those things. All that this drawing is doing is bringing that information in and making it available to you, so if you want to display it, you can. There's tons of information available on the drawings page. Okay, and if you, now that I'm looking at it, I may actually want to, instead of dimensioning all my lines here, I may actually want to put it right on the much more pretty and easy to see isometric view. Some companies, it depends on company procedure, for their first page will only have this isometric view, and they may have a bill of materials on the front page. It depends on the company. There's a million ways to do drawings correctly. I'm only going to be showing you one of them. Okay, so I'm just deleting my my balloons now because I'm going to put them on this assembly instead. So I'll go back into my annotation tab, click balloon. Oh, I wonder what happens when you click AutoBalloon. Huh. It automatically balloons out what all the parts are. Oh, that's cool. Ah, I didn't accept that. I'm gonna do it again. So hot. Oh, it's fantastic. And then I gotta move this back onto the page. So that's a neat other feature. You wanna automatically label all of your parts. This is what it does. And apparently I missed piece 6 when I did it, which is that vertical tube. So thank you, AutoBalloon. Good times. In a professional drawing, you need to label what parts are what. Okay, your first page, what I will expect out of you, because I want you to do this right, is your first page should show the assembly. And on your assembly, you should have bubbles or balloons that show what parts are what. If you're doing this in AutoCAD, you'll have to draw the line, create a circle, write a letter in there. You'll have to do it automatically because AutoCAD does not import the kind of information that SolidWorks does. Quite frankly, this is far easier in SolidWorks. So I'm sorry to everybody else. But this is generally how your front page would look. And you may have a few comments. Again, I'm not going to touch comments until the next video because we're going to be discussing detailing, bill of materials, sheet formats, everything done. But this is how I want your first page to look. Now your second page, we're going to put the bill of materials at the end. So the second page, I go down here, I can rename this sheet. Rename, I'm going to go ahead and call this assembly. Okay, that's what the drawing number name is. I'll go in here and I will click add sheet. Okay, I'm going to rename this sheet right now. I'm going to start by going top down. Biggest part of the assembly to the littlest part of the assembly. Most of the pieces that we have are in that sub-assembly that we created that was the extruder parts. It has the two rods, the plate, and then the extruder parts on those. We're going to go ahead and hit the rest of the model before we get into that assembly. So first thing I want to start with is I'm going to go into view layout. I'll go into model view. And then we don't have that one open right now, so I'm going to have to go browse for that file. It should be right here. This is my structure. Open it up. It lets me... Oh no! I pushed SolidWorks too far. Somebody play taps. SolidWorks, I know my problem. I'm doing streaming software and I'm on the internet at the same time, okay? I know what my problem is. So this is lovely. Once again, you signed up for this class so that you can watch your professor struggle with things. Next, I'm going to be struggling with how to open a container of milk. I'm going with the bag milk too. Make it extra frustrating. Dang it, SolidWorks. You end. And I just want to restart SolidWorks. I do not want to try to repair SolidWorks. I think it's fine. Meantime, I'm going to let you look at me. It's your punishment for my computer not working well. I'm a dinosaur. I'm not very good at impressions either. I'm sorry. Although, every once in a while, turn it back out my... Hey, Adrian! Adrian! I probably just defamed all of Sylvester Stallone's family. I'm not sorry. Not sorry. See, I record these videos so that I can make a fool of myself, and it's on the internet forever. You're welcome. Okay. So now, rather than opening up the assembly first, I'm going to be nicer to my computer by hitting new drawing, going back into this, going to avoid the lengthy expose that I gave you earlier when developing all of this, and I'm just going to try to recreate what I just had. Browse, give me that assembly, open. Okay, got my model view, got my projected view, got my other projected view, got my other projected view. And I'm okay with this isometric view being on top of the others because I can always grab it and drag it. Okay, so I want to take this, I want to make this shaded. I'm going to my annotation, AutoBalloon, hit yes because I like it, move around my bubbles so that they're not touching anything or outside of the page. Okay. So this is close to where we were last time. I'm going to shrink this so that I can grab it. Or maybe I can't grab it. My page is down here and I need to grab that page. Oh, nope. Oh, I forgot to say. Yeah, thank you. Thanks, Grace. The world's greatest YouTuber. So I just got this back. I put this back together. Grace, I need to hire you as like my professional person who tells me I'm doing things wrong. You're very good at that, and I appreciate it. Okay, how do I... Okay, so I just created a new sheet. I can right-click on this and rename it. I'm not going to because that's the last time that's where it exploded. Okay, you'll notice over here on the left side, man, this is bothering me. I can't reach down here. I don't know how to move this. I don't know how to scale. Whatever. You'll notice that the drawing views show up. Each of the individual drawing views, this one comes in, this indicates that it's a model view. These three indicate that they are projected views. I can open this up and I can actually see what that model view is of. And here it's of the assembly. Now here, this new sheet doesn't have anything in it. It just copied the same sheet format as the one before. I'm going to go into my view layouts, standard 3 view, click browse, go ahead, hit structure, open, should automatically pop it in right there. Okay, and I click on this. Now this is just one model view, 2 projected views. I'm going to create a brand new projected view of that model view. I want it to be an isometric view. Isometric views are nice because they give a little bit more 3D perspective. Since this is a complex geometry, it's not really easy to see everything from any one view. Okay. Now the difficulties we have here is this just looks like a microwave. I don't know what that looks like, but it does not look like a microwave. And that is a box. What I'm going to do here is I'm actually going to enable hidden lines on the model view, and what it'll do is on all of my projected views it will also enable the hidden lines. I've picked the wrong one. Okay, so all of my views now have hidden lines. I can select one of the projected views and change it back if I really want to. It doesn't hurt any. Now this is actually opening up the actual part. When I opened this part, I did not specify that part to be red. I only did that in the assembly. So here, this part has no idea that it's listed as red elsewhere. That was not information that was stored in this part. It was only stored in the assembly file. So once again, the assembly file does not always communicate with the part files, and the assembly file does not contain all of the information from the part file. The part file communicates with the assembly file, which then you can communicate with the drawing file. But if we really wanted to make these kinds of edits, if I really wanted this to be red, I would have to go into the part file and change it to be red. I don't. I don't care enough. Now since on this first page, See if I can select it. Can't see it, but let me see if I can. Oh, I can move it! Yes! I found a very small window I could select. Now on this page, I have all of these parts listed, and this structure is noted as part number 1. What I'm going to go in here, just for consistency's sake, I'm going to go ahead and I'm going to create, if I click on this view, I can create AutoBalloon, or I can click Balloon. Both of them are going to be the same thing. I'll click AutoBalloon, because why not? Hit yes, and it shows, okay, this part is part number 1. Now the importance of that is, because now I know this is listed as part number 1, on this sheet, if I'm looking for, oh, I need to know how to build part number 1, or I'm not really clear what part number 1 is, it's listed here. And that's nice. Now let's say this is not my favorite view of this drawing. I don't really like it. It looks like a microwave here. I actually want to see the back side of this. If I click on this model view, we have only on the model view do you have this orientation tab open. If I click on a projected view, you don't have that orientation tab. Why? Because the orientation of those projected views are dependent on the model view. But I can click back on this model view and I can say I want to look at the back side of it. Okay? And then what it'll say is, it says, okay, all of your projected views are now going to change. I'm going to hit OK because I like whimsy. Now this flipped around, this flipped around, this flipped around, everything flipped around, which kind of makes dimensions, if you change the party orientation when you have dimensions in place, it screws everything up. So if you need to do any modification to the orientation, make sure to do that before you put in dimensions. Okay? We'll cover dimensioning at the end of this video. So we've got these 3 views now. Now what I'll do is, I'm just going to say for the next sheet, I'm going to add a standard 3 view model of the hot plate. Hit open, automatically inserts them. The scale is 1 to 8 on this sheet. Awesome. This shows it has hidden lines already existing, I think. Nope, does not. I'm going to make them all show. And this just shows that, okay, you've got, here this shows there's an embedment here, and then we got holes there. And apparently we have an embedment there too, but that's not visible. So the question is, I can't see what is this line doing? Like, I got this line right here. If I were to draw this line right here coincides with this inner spot here. But what is this line? What does it even do? What does it mean? What we can do here is we can say, well, I would really like to have a section view of this drawing. I don't feel like this view here does a very good job of explaining it. Now, I don't actually like this. I'm going to go ahead and go with the top. Oh, that's not it. It's top view. Oh, I would click on left and then say top. I like this view right here. These 2 views don't really show anything. Okay, I might keep this view just because it's there, but quite frankly, this view up here doesn't show me anything new. Why do I have it? If there's nothing I can dimension, if it doesn't show me anything, if it just looks like a bunch of weird lines, I'm going to go ahead and delete that. That projected view isn't worth anything to me. And instead, I'm going to replace it with what's called a section view. So I'll go ahead and select my model, click section view. Okay. Now what the section view wants to do is it says, okay, what do you want to do? Where's your cutting line going to go? Is it going to go left and right? Is it going to go up and down? Is it going to be at an angle? Is it going to be a rotated, aligned angle? I want mine to be up and down. So I will start with here, and then you get to pick where you're making the cut at. What a section view does is it basically, if you were to take a saw, cut this piece in a certain location, you would be able to see, flip out that piece, you'd be able to see what that piece is. I'm going to go up here, right between these two holes, and I'm going to create a cut right there. Okay? So that's where I want my section view to be. It automatically creates a section view right here. Now, if you'll notice, my section view is very boring. Why is it boring? Well, it's because at that area, it's a completely solid piece of metal. Yeah, not a huge fan of that. So I'm going to go back in this. I'm going to click yes on this. I'm going to go ahead and select this line, and I think I can just drag this. Yep. So if I drag this, and hit OK. Oh, you're supposed to update. It didn't update. I'm sad. Oh, it's supposed to do that. Why isn't it updating? There are different types of sketches that you can have. You can make the hatching bigger. The hatching basically shows the material that's been cut. It's kind of like saw marks from where the saw cut. If you don't see any hatching on a surface, it means it's open right there. I'm going to go ahead and delete this because this is not working the way I wanted it to. Okay, trying a brand new section view, and this time make that section view be right there at the holes. I'll hit OK. So this is section B to B, and now you'll notice section B shows it's right along that line right there, and it shows where these bolt holes are and how they go all the way through. If you had bolt holes that had a unique shape or something, you could use a section view to show that off. If you have a unique geometry that's only present in the middle of a piece, you can use a section view to really show that off. It doesn't hurt to use a section view here. This probably doesn't tell you a whole lot of information. There's nothing really you can model off of. But that is, section views are something that you can use if you want to have a more detailed view. Okay, another thing that you can do is you can do a broken out section, which will actually basically take a section view and it will allow you an additional cut. You can do a detail view, which allows you to zoom in on one piece. So let's say, I'm not going to do it on this page. Let's say for the next view, I'll do a standard 3 view, and I will do it over my extrusion assembly. So here's what my extrusion assembly looks like. I'll go ahead and grab this, create a projected view. Difference between a projected view and an auxiliary view is an auxiliary view is aligned with a certain surface. So if you have a surface that's at an angle and you want it to project as if it is flat, you can do that. Like if you have a solid panel or something that has a flat face and you need holes to be drilled perpendicular to that face and the hole spacings are located at an angle, there's no real good way of doing that in SolidWorks other than using an auxiliary view. I hope you never have to encounter that, but that option is available if you do. Okay, so here is the assembly. I'll go ahead and take this and I will make this shaded like I did with the other assembly. Just shows different parts, and then I will also go in here and with this selected I will once again AutoBalloon. Okay. Once again, every time you have an assembly, every time you have a part, it's always good to put balloons on there because it lets you know what pieces comprise that and where they can find them to assemble them. Now when I hit AutoBalloon on this, it only labeled one of my threaded rods. So just doing AutoBalloon isn't enough to really say, well, this is this is good enough. I'm going to go ahead and put that second balloon on there to signify that there's 2 of part number 2. Okay, so then this is my next page. Page after that, I'm actually going to go into sub pieces. So a whole page structure here is devoted to start with your big assembly, break it down into pieces, go into sub assemblies, break those down into pieces, go into further sub assemblies, break those down into pieces. So again, you start big and you end small. Okay, so on this page, I'll go ahead and, no, I don't want to do that. That's not what I want to do. I don't want to model items. I'm going to go with the model view. Go ahead and here I'll start with my carriage, because that was the piece that I built everything off of. So it looks like got my standard 4 views. I'm going to go ahead, select this view, and turn on hidden lines. Now it does make my this view right here look pretty ugly. So I'm going to go ahead and we're going to go back to just having that be a solid no hidden view. Here these lines show that the lines cut all the way through. That's what I want to show off for that piece. Next page. Oh, I should probably save this quick. Surprised this hasn't broken yet. And I'm going to go ahead and save this as Pancake drawing. Please save before you break. Oh, and now you'll notice that, yeah, that it updated the drawing number to Pancake drawing, and now it's gigantic and huge, and I'll have to go back and fix that. We'll do that later. That'll be a next class thing. Okay, for right now I want to get the drawings in, then I want to start doing some dimensions. Dimensioning is very similar to what AutoCAD has. AutoCAD's Smart Dimension is, in my opinion, actually built after SolidWorks' Smart Dimension tool. I do believe SolidWorks' Smart Dimension tool came first. AutoCAD had very specific dimension styles you had to use for certain pieces. SolidWorks kind of pioneered that. So the next thing I'll do is I'll have batter storage here. There's no need for me to have a side view because it's identical. Go ahead and escape. Now here there's no, I mean, I guess I could click on this and hit hidden lines. It's not very exciting, but whatever. Just shows that it's hollow. So that's fun. Okay. Now in my next sheet, I'll go in there and add in my extruder nozzle. Now once again, I don't need a side view on this because it's very round. Scale, the sheet scale automatically updates to 1:4. I'll put in my standard 3 views. I modeled this as a hollow tube. Nice work, Cal. Great, that's all I need. And then my last piece is I have model view. I'm going to add. Oh no, that was the nozzle. That was not the threaded rod. Right. Threaded rod comes in like this. Wouldn't do me any benefit to have an isometric view on that either. Okay, this is absolutely every one of the parts I have in my entire assembly. Okay, and I have them listed out on each of these pages as I go back through. Now that I have them all laid out, I go back and I should probably click on here. I make sure that my balloon is on. The next thing that I do is I start putting in my dimensions. A well-dimensioned drawing is something that anybody could follow to exactly build everything that I have already made. Okay, so here I'm going to go into annotation, I'm going to go into smart dimension. Now, in most of SOLIDWORKS, smart dimension is used to define the size of an orientation. Here we're using smart dimension to actually just read the dimensions, much like the dimension in AutoCAD. So I'm going to say this is 20 inches. The distance between these two lines is 10 inches. I have a nice viewing angle in here of 12 inches by 6 inches. It moves. If you click on that feature, it automatically moves. Put these together. Okay, so this gives me my general overall dimensions. Here I can click Smart Dimension and dimension the size of this window here. This is 16 inches. This is 14 inches. I can click on my circles. Oh, didn't like that. I'm going to go ahead and click on the crosshairs of the circle. This appears to be a little bit outside the top of the page too, so I may need to move this down. This is 9.5. If I pick that and this, ooh, 180 degrees. Now, why did I get 180 degrees? Because I picked two lines. SOLIDWORKS is very particular about which part of the crosshairs you pick. So if I pick this horizontal line, and I zoom in and I click on this horizontal line, then it'll give me a 13.5. If I pick two of the vertical lines, it will give me an angle, which is not the best. If you have an angle, you can dimension it that way. Pick two lines that are not parallel. Okay, I'll dimension the hole sizes here. It's 0.25 inches. Ooh, I should dimension this depth here. It's 2 inches. Probably need to move that so that that's actually readable, but whatever. Okay, I'll want to dimension the whole depth. That'd probably be easiest done on this drawing, because this drawing is the cleanest. Go ahead and pull that out. It's 1 inch. Here I've got all these edges are filleted. I will go ahead and dimension that radius. Okay. Now with this, it's a little ugly. I need to move this down to save some space. I need to move this down. Move this down. Move this up. And then I need to move this down. I'm going to go ahead and move this inward. And move this down. So I'm just cleaning it up so that I can read my dimensions nicely and I can actually see what each of these dimensions are looking at. Okay. Well-dimensioned drawing, everything is easy to read and determine what it is. Now from these dimensions themselves, you should be able to figure out how to build this. It's not hard to build, but these dimensions, as complex as they are, should tell you exactly the building procedure for how to construct this item. You may submit this off to a machine shop and then they come back and say, well, what's this dimension? And you have to add a new dimension in. But that's an iterative process. You always got to start somewhere. I'm going to say we're going to go ahead and say we're done with sheet 2, with the exception of adding a note. I'm going to go ahead and write in a note right here. And what I want to say in this note is the structure is constructed using HDPE, plastic, and it's going to be injection molded. Into a solid part. Go ahead and click. Escape. Great. Now this note is gigantic, so I'm going to go ahead and... Hey, you're supposed to be... Going to go ahead and edit the note, shrink it down, move it in place. Okay? Having notes like this are good to indicate the material choices, how it's made, what it's made out of, any specific things that have to be done in the assembly process. Like if I wanted these holes to be threaded, I could do a leader off of that and say it's UNC 25 or 20, 1/4 20 holes. And then that would say thread those holes so that you can screw a bolt into it. Okay, so that's sheet 2. Sheet 3, once again, we just go through, we dimension everything. Okay, you got to give your gross part dimensions, you give your individual part dimensions. You can use the SolidWorks existing features if you really want to. It doesn't hurt anything. Here, using that feature makes it nice, it automatically spaces it. I'll go ahead and dimension these holes. And I'll dimension the spacing between the holes. Yes, I want it to be driven. B is already located somewhere. It's trying to tell me that I'm dimensioning to section B, which is an accident. Go ahead and zoom in, pick that line, pick that line. These holes are 9.5 inches apart. Okay. Now I have fully defined this piece except for one thing, and that is the distance. I guess I should be in Smart Dimension to do that. But the distance of this hole. Okay, so this is again fully defined. I keep going through with all of these. I'm going to go ahead and say this one, because it's already got, oh, I forgot to put in the, I'll go ahead and throw in a projected view here. Be done. Take this, move it over here, annotation, AutoBalloon, yes. Although this part is not number 1. So this part is actually number 6. So I will, nope, this part is number 2. I need to go back and figure out why that's showing up as 1. But it shouldn't. Ah, dang. Oh well, we'll talk about that in the next video. Then this has all the pieces annotated. None of these parts are numbered correctly too. I'm going to have to cover that in the next video. I'm going to go ahead and go to the last one. This is just a threaded rod. The nice thing about this is, quite frankly, you don't even really need to dimension it. If you're a good SolidWorks person, you will dimension it, because you should. But some companies simply won't because it takes up space in the drawing. What I'm going to go ahead and do is I will draw this, click on it, I'm going to add a balloon. Balloon is also going to say 1 because it's still broken. And then I'm going to add a note here at the bottom that says, make it this big, rod is a 1/4 20 UNC threaded rod cut at 16 inches long. Okay. From ASME A107 steel. Something like that. Okay. It's not the right notification for that steel, but I don't really want to look it up right now. That's all that would be required from this sheet. Okay, so the simpler parts get really simple. The more complex parts, like what we had on sheet 2, this does get a lot harder. But what I would suggest you do is start building your drawing file, start putting in the dimensions, start getting the notes in, signifying what we want. Next week, we'll do a little bit of cleanup work. We'll talk about these friggin' note number things and why they're all wrong. And then we'll update the sheet header, and that'll be it. So I won't see you on Tuesday. I will see you next Thursday, and next Thursday is the last lecture we have for this class. So I will see you then.